Hey everyone, and welcome to Building SaaS on AWS, the flagship show for building SaaS on Twitch. So, my name is Gunnar Grosch. I'm a developer advocate at AWS, and if you're building or planning to build a SaaS product, this is the show for you. This is a bi-weekly show where I bring on experts in the SaaS field to dive deep into SaaS-specific topics so you can learn more about building SaaS on AWS. And this week, I'm happy to be joined by Islam Mahgoub and Anthony McClure. Welcome to the show, both of you.
Hi, welcome, Gunnar.
Great to be here. Thank you, Gunnar.
Yeah, Anthony, you're a regular on the show, sometimes just in the chat, but great to have you with us.
Thank you very much.
Let's do the quick round of introduction. Islam, let's start with you.
Yeah, sure. My name is Islam Mahgoub. I am a solutions architect at AWS. I work with ISVs, independent software vendors, and I help them build on AWS. This involves migrating their software from on-prem environment to AWS, and also involves like modernization and transformation to SaaS or software as a service.
Welcome, Anthony.
Excellent. Thank you. Yeah, my name is Anthony McClure. I am also a solutions architect at AWS. I hail from the AWS SaaS factory. So we often are working closely with Gunnar and helping to put the show out, as well as being the home for SaaS and SaaS-based solutions on AWS, and specifically within the partner network. We like to work with our partners to help them to build SaaS solutions, invigorate their businesses when it comes to SaaS. And very happy to be here today.
All right. Welcome again, both of you. So, if you're a regular at this show, you know this already, but otherwise, we try to make this show interactive. So, if you have any questions, any comments, just put them in the chat and we'll do our best to answer it as we go through this hour. And as I mentioned, each week or each show we have a specific topic, of course, and this time the topic is data science workbenches in SaaS with Amazon SageMaker Studio. That's a lot for a topic, so I think we need to break it down and maybe start off with, Islam, what is the problem we're trying to solve?
Great. So many SaaS providers are using artificial intelligence and machine learning for addressing problems like fraud detection or personalized recommendation, or sometimes like accurate demand prediction as well. Some of these SaaS providers choose to implement these AI and ML capabilities themselves and deploy it in a multi-tenant way and make it available to all the SaaS customers. Some other SaaS providers who have like more sophisticated customers would like to allow their SaaS customers to actually build ML capabilities themselves and integrate this with the SaaS solution. In this case, they need to be equipped, like the SaaS customers need to be equipped with a data science workbench within the SaaS itself that they can use for building ML models and integrating it with the SaaS.
And maybe you can give an example of one of those use cases.
Right. So think of a CRM SaaS solution, right? One of the functionalities that you usually find in a CRM is the ability to identify customers or buyers with a propensity to churn, basically. Sometimes this functionality provided by the SaaS is like simple, based on some simple statistical analysis, for example. Some of the customers may want to like override this default implementations that comes with SaaS with a more sophisticated implementation that they build themselves and train using ML and artificial intelligence. So they build a model themselves, train it on their own data stored in SaaS, and then deploy this and consume it from within the SaaS.
You know, we're seeing, I think, an uptick in the marketplace as well at the SaaS factory of customers not only wanting to build SaaS, but bringing in and wanting to do machine learning of various different ways. Are you seeing that as well, Islam, in your practice?
Yeah, definitely. Machine learning and artificial intelligence is one of the hot topics. I mean, it comes up very often in my conversations with different software companies. in UK and Ireland.
So, all right, so now we know the problem we're trying to solve, and you gave a good example of how that can be put in practice. Then for that first part of the topic then, data science workbench. What is a data science workbench?
Yeah. So data science workbench is basically an integrated development environment. This is a very familiar concept for programmers and developers. They used to use it in the past for any programming language or any custom applications they are building. You can think of data science workbench as an IDE, integrated development environment for machine learning development. And it can help you with like different tasks related to ML, whether it is like data processing, feature engineering, training a model, debugging it, deploying it eventually, and monitoring it as well.
And the AWS solution for that is AWS or Amazon SageMaker Studio, right?
Right. So SageMaker Studio is what we are using in this solution for actually providing the data science workbench to the SaaS customers. SageMaker in itself, I mean, it is a complete end-to-end ML service that can help you with these different stages of ML development, whether it is data processing, as I was saying, or feature engineering, or training, or deployment as well. And the SageMaker Studio is like this IDEs that I spoke about that help you as an ML developer to implement these various tasks. And it gives you access to all these SageMaker capabilities like training jobs capability, processing jobs, data wrangler for data processing and feature engineering as well.
Right. Looking at this from the SaaS perspective, then what are reasons that could motivate a SaaS provider to build a data science workbench within their SaaS?
Right. The key benefits that SaaS provider would get from embedding data science workbench within their SaaS is basically avoiding this situation where the SaaS customers have to like switch to another platform like data science platform, machine learning platform, and worry about like how to export the data from the SaaS, transfer it in a secure way to this other platform, and then ingest it. This is usually like involves a lot of heavy lifting, what we call undifferentiated heavy lifting. It is a distraction from the business problems that SaaS customers want to solve, right? And always like there are funny discussions with InfoSec team and for making sure that this integration, this transfer for data is secure. And in addition to that, like building and managing such data science and machine learning platform separately, like is also like not an easy task. So rather than doing that, they can leverage a managed service provided and managed by the cloud, like SageMaker. Another upside of this approach is the SaaS customers will actually get access to the SageMaker and the very broad set of capabilities that comes with it. So we are not just putting the SageMaker in the hands of the SaaS provider, but we're also putting it in the hand of the SaaS customers. So They get access to all this rich set of capabilities, and they can use it for building and augmenting the functionalities that comes with SaaS.
Yeah, I would add to that as well that since SageMaker itself is built on top of existing AWS concepts and services that our customers are familiar with, that moving into SageMaker environment for existing AWS customers, for instance, is a logical and easy step for them to move forward with.
Right. And we are 10-ish minutes into the show. I think our viewers always want to see stuff as well, not just three talking heads. So Islam, I think it's time to show an architecture of that you're proposing to address these requirements that we talked about.
Right. Great. So I'm showing now a diagram that represent the high-level architecture of the examples that we just spoke about, a CRM application built as a SaaS. At the top of this diagram, you see like three front ends. The first one is the landing and sign up application. This is the application used by SaaS customers to subscribe to the SaaS offering and create a tenant for themselves. In addition to that, there's another application called CRM app. This is basically the applications that provides the core functionality of the CRM, like using it for managing customers, updating the customer like information, managing opportunities, managing product feature requests, the product catalog, these kind of core CRM functionality. Another application is the admin application, and this is used by the SaaS providers themselves to manage the SaaS offering. This involves like activating tenant, deactivating tenant, changing the tier of one tenant, monitoring the consumption of these different tenants as well. The first two applications, the landing and the sign-up app and the CRM app, these two apps are used by SaaS customer, while the last one is used by the SaaS provider. The first app usually doesn't require authentication, but the second two apps, the CRM and the admin app, require authentication, and that's where Amazon Cognito come into the picture. While we have used Cognito, or we assumed Cognito for this solution, but you can use any other OAuth compliant identity provider, basically. In terms of the backend services that actually serve these front ends, we have two sets of services. The first one is the apps, what we call app services, and this involves like customer management microservice, opportunity management microservice, product catalog. It depends on what functionality you are building in the SaaS application. In addition to that, there's another group, which I called here SaaS services. Sometimes are called shared services as well. And these are more focused on managing the SaaS and the multi-tenancy aspect of it. So there's one for registration and creating a new tenant, another one for managing these tenants, as I said, like activating, deactivating, changing tier, all these kind of things, and user management service as well. So this is the architecture you start from. Like your architecture might be slightly different. That's okay. The concept that we're going to discuss here will be applicable as well.
Yeah, and I think this is quite familiar to the SaaS builders out there, or the SaaS curious maybe. This is similar to what we often talk about on this show, this type of setup for a SaaS solution.
And if any of our developers out there are interested in building a SaaS solution like this, we do have reference architectures, one specifically for EKS, for instance. In this case, they can help to build out this sort of architecture for you from a general SaaS perspective.
So in this slide, in this diagram, I'm trying to show what are the changes you need to make in this architecture to embed or to build this data science workbench within the SaaS. You will notice here I added a new group of services in the middle, which is called data science services. These are primarily two microservices. One is data management, and this will be responsible for extracting the data from the SaaS data store, and putting this in an S3 bucket and make it accessible to the data science workbench. And this will accept all kinds of filters that the data science usually want to apply on the data extracted from the SaaS. And also if there's like a requirement for data masking or something of that sort, this can be implemented in this microservice. In addition to this data management service, another service I added here, which is called Data Science Workbench Management. And this is more for provisioning this data science workbench for different tenants. By default, not all the SaaS customers will require this sophisticated capability. Some may be just happy with the default implementation that comes with SaaS. Others may be like more sophisticated and want to customize this. So those will require the data science workbench. So the data science workbench management microservice will allow those tenants to request the data science workbench, and it provisions it for them. And it also integrates it with the application and allows the users to launch it from within the SaaS. At the very bottom, you find like this, what I call data science workbench. And this is primarily, as I was saying, SageMaker Studio. This is a SageMaker features that I'm using for building this embedded data science workbench. And the prerequisites for that, primarily the S3 bucket that will contain the data extracted from the SaaS.
And looking at this architecture, I can see that you've put the data science workbench in a separate account. Can you tell us a bit about the rationale behind that?
Right. So the same like any other SaaS component, we usually have to consider like multiple like isolation models, tenant isolation model, whether we should go for silo model or pool model. and the data science workbench is not an exception to that. So we need to like think whether we should, or decide whether we should go for a silo model or pool model. For those who may be hearing this for the first time, pool model is more like a shared infrastructure or cloud resources for all tenants, while the silo model is more like a dedicated infrastructure for each tenant. And there's another model, which is the bridge model, which is like a combination of both, like using the silo for some of the components and using the pool model for other components. Here we decided to use the silo model for the data science workbench. The key reasons behind that is to simplify the security or the IAM policies primarily. If you go for a single SageMaker domain and make this multi-tenant, you will have to create a complex IAM policies to make sure that you don't get into a situation where a tenant accesses another tenant data. And also some of the APIs, like controlling the data retrieved from this API is sometimes challenging and not very straightforward, right? Another reason is that this environment will be used, the SaaS customers will be executing code in it. So they will have a very wide permissions to get the agility they need to build themselves ML models. So from a risk standpoint, isolating this data science workbench for each customer, its own account, will reduces the chances for any like cross-tenant access scenario or any security risk, basically.
But you're not saying that you couldn't use the data workbench in a pooled model. You're just saying that in this case, for those reasons, you opted to use it silo.
Yes, you can, but expect some complexity in managing the IAM policies and permissions.
Right, and Anthony, you have these conversations constantly, I think, about different services and deciding between pool or silo.
Yeah, this is absolutely a very common question, and generally one of the first things that we end up discussing with partners and customers that come to us and have a discussion about how to architect SaaS is this concept of tenant isolation. And the story itself, as Islam was saying here, is when you're a silo model, it's more direct, right? It's obvious that how the isolation is taking place. Gets a little bit more muddy and difficult to do in a pool model. However, both options are certainly viable, and there are solutions to doing both.
Right. Another like little advantage is the billing. If you have like a separate account for each tenant, you can easily like calculate the charges on the ML front for this specific tenant and charge it back. But as Anthony said, the two models are possible.
There are complications, of course, that do arise from having your tenants across accounts as well. As can you show us a little maybe what that looks like, Islam?
Right. So in this slide, I'm trying to show how the account structure will look like. Right. So this is you see here at the bottom we have one account for SaaS. This is mainly for the pool, for the components that are implementing using the pool model, and like the microservices and the databases and the other components, the web applications that we spoke about. When it comes to the SageMaker, as I said, the approach I'm proposing here is to have a separate account for each for the data science workbench of each tenant. So you can have many of those, one bare tenant. And then you have different OUs, organization units, under which these different set of accounts live. So you can, having these separate EUs allows you to differentiate in terms of the guardrails. You can like limit the permissions for whatever get executed in these accounts using these guardrails. Right. Also, we are using the control tower. For those who are not very familiar with control tower, it gives you a framework for building like a well-architected multi-account structure, right? And which is aligned with best practices and also allows you to, it gives you this account factory capability, which enable you to provision these accounts that you will need for each tenant with a specific baseline. Under the hood, it uses other services. It's more of like an orchestrating service Under the hood, it is using the AWS organization, which allows this hierarchy I'm showing, like organization units and accounts under these organization units. It also uses Service Catalog. Service Catalog, for those who don't know it, it is mainly, it allows you to bundle like deployment patterns or cloud infrastructure in the form of a product, and then publish this product within your organization and allow different teams interested in a specific deployment pattern to just use these products rather than building variants of the same architecture and lead to inconsistency. So they can be like, for example, a product for a 3-tier architecture. And then you give access to your organization or to different teams on this product, and whoever needs to build a 3-tier architecture, 3-tier based application, they can provision this product. Here it is used as part of the control tower to expose this account factory capability. Whenever you want to create an account, you actually provision a product on Service Catalog that creates this account for you. And CloudFormation, of course, for like the baseline that is needed on these different accounts created. You will see here also we are aligned with the multi-account best practices, like having separate log archive and audit accounts across the organization, so you can have this centralized view for what is going on in the entire environment. Yeah, and this management account at the top. So this is how we see the account structure for a deployment like what we just explained.
And Anthony, this isn't, even though it at first glance it might look like a lot with a lot of accounts, but this isn't uncommon in a SaaS architecture.
No, in fact, it's not uncommon, I think, in a general architecture, or at least following best practices for an organization and moving into AWS. So there are definitely many moving parts that can come along with an architecture, a well-built, well-architected architecture such as this one. But this is just a piece of the puzzle, and we certainly indeed see this in SaaS customers as well.
So if you just joined us, this is Building SaaS on AWS. I'm Gunnar, I'm joined by Islam and Anthony today, and we're looking at, well, using machine learning in SaaS, and not only for the SaaS provider, but for the SaaS customers to have access to a data science workbench. And Islam is presenting a solution for how that can be done, basically by integrating with Amazon SageMaker Studio. And maybe, Islam, you can show us how the process for provisioning this data science workbench looks like for one of the customers.
Yeah, the diagram looks very complicated. So what does this actually look like to do one of these?
Right. So yeah, let me walk you through this process. So first, quickly, as I said, we are going, the control tower exposes this account factory capability using Service Catalog. So we're going to use Service Catalog for provisioning accounts. Also, another interesting feature in CloudFormation, which is our infrastructure as code tool, is what is called stack sets. Stack sets allow you to provision and manage CloudFormation stacks across multiple accounts and multiple regions. And we're going to use this feature as well. So whenever we provision an account, we want it to be, whenever we provision an account for this data science workbench for one of the tenants, we wanted it to be bootstrapped with the SageMaker environment that they will need for having this data science workbench. So for that, we are going to use a stack set. And this stack set, we are going to attach it to the OU under which the accounts, the ML accounts for different tenants will be created. This means whenever you create an account under this MLU, it will come with the stack defined by the CloudFormation stack set, which includes the SageMaker resources you need. The flow will look like that. So first, the tenant administrator logs in to the application. They will go to the data science tab, and then they will be presented with an option to provision a data science workbench. This will trigger a request to the data science workbench management service. It is a multi-step process. So we are going to use a DynamoDB table, like an item in DynamoDB table, for tracking the status of the provisioning request. So the first thing is I add an entry for this request with the status in progress. And then I call the Service Catalog API for provisioning a product. The product in this case is Account Factory product. And this will trigger the account creation. once account is created, the stack set will do its magic and deploys the SageMaker stuff into it. And then, and Control Tower has this feature called lifecycle events. It basically emits events like based on different events. It emits messages based on different events. One of these events can be the completion of the account creation. Once this is done, a message is emitted to Event Bridge. Event Bridge is a managed event bus service, serverless one, which allows you to like capture events published by different AWS services like AWS Control Tower. You can also use it for capturing events from custom components or microservices. Here we're using it for capturing events from Control Tower, which tells the account provisioning is completed. This event is then published to an SKS queue via rule on Event Bridge. And then the microservice is pooling this queue periodically to get these events. Once it receives this event, it knows that the account creation is completed. So it updates the status of the request saying provisioning is completed, and then goes to the tenant management service saying, this is the account ID provision for this customer. Keep it, store it, because during launch, we'll need this account information to be able to access through within the SaaS. Let me show you some of these concepts on the console.
Right, so Islam is doing a quick change in his screen sharing here. Let's see. We're not going to time you, Islam, so no worries. All right, so did you get all of that, Anthony, following that process?
Yeah, I mean, it certainly sounds like a good flow. The process using a lot of different AWS services in order to generate the account and ultimately get those services provisioned into the account for the new the tenant that's coming into this multi-tenant solution. Excited to see what it looks like, though, actually in the console.
Right. So if you looked into this is a Control Tower console. We'll go to the organization tab. Here we see the hierarchy that I just presented that I showed in one of my diagrams. So you see here we have the root, and the root we have this MLOU, and here we have like multiple accounts, one for each tenant, and this is where the data science workbench lives. Right. So we have here two accounts for two tenants. Right. Let me show you. So to create a new tenant, we're going to call this API for provisioning a product. Let me show you this product. So first, I'll go to service catalog. So here you see all the products in your organizations are listed here. So the one that I have right now is the Control Tower account factory. And you can see here the details of that, like how many times this product is provisioned, and you can see a list of all the provision products from all the provisioning of this product, basically. So what I'm going to do now is to simulate a call to this API to provision like a new account for one of the tenants. So I will do this from Cloud9.
And if you're not familiar, Cloud9 is an integrated environment that you can launch right from inside of the AWS console to gain access to your AWS resources, including running code and executing command line interfaces, many different capabilities.
Right. So this should be done. I mean, you will call this API from your code, right? You can use SDKs for. We have many SDKs for. We have SDKs for different languages, so you can use one of those to call the API. Here, I'm going to use a command line, right? So this is the command I'm going to use that will trigger this.
Cloud9
is always a bit small on live stream, so maybe you can explain what the command does, Islam.
Right, I'll do that. So you will see here I'm calling the API for provisioning a product. I'm providing the product ID. I'm also providing the specific version of this product that need to be that I'm going to use for account creation, and I'm giving a name to this provisioned product. In this case,
the creation of the service catalog product itself, that would be done normally by the development team or cloud services team within the organization?
Yeah, so this this product itself is when you enable Control Tower, this product get automatically added to your management account, right? And then you can use it. These details like the product ID and like the version, you can get these details from the console. Like here, for example, if you go to products, this is the product ID. If you click on the products, there are multiple versions, so you can actually like take the version from here, or you can use APIs as well.
Excellent.
Right. So I'm going to run this command to simulate a call. Just I have to set the region. So export. Again. Right. I will have to. There's one more thing that needs to be done here, which is actually providing the parameters of this account, like what is the account name, what is the email address, and all these details. I'm going to set these.
And if a customer was doing this in an automated fashion as well, from inside of their own admin tooling, these API calls, there's various different ways of doing this, of course, depending on the environment, the programming languages that your team may actually be using. But what Islam is showing here, executing directly from the command line, this could all be embedded into what we like to call the onboarding process, or the process that we actually do to bring in a new tenant. So it can be done in a manual way that we're showing here, or as part of an overall flow.
Right. If you go to the service catalog now, right, look into the provisioned product, and let's refresh that. So there's a new provision product being created. It is under change, right? And this, once it is completed, you will see here in the control tower, a new account added under the MLOU. So it'll take some time, so we'll not wait for that, right? But let me show you the events part, the event-driven architecture part. So I will go to Event Bridge. So we'll go to rules. So here I have a rule which is called Control Tower Create Managed Accounts to SQS. And this rule, what it does is it captures all the event published from Control Tower that tells there's account, there's a event for like account creation, and then forward this to a target. The target in this case is the SQS queues that I was showing in my diagram, right? And then if we go to SQS, I have some events from previous execution of this process. So I will show you that. I go to the SQS queue and then click on send and receive messages, pool for messages, and then I can click on one of these. So this is an example of these messages emitted by the control tower. Let me show it to you. So you go here. Just formatting it, right? So here we see like the source of the event, control tower, like the account ID, and then details about the account, like the organization unit it's created under, the account name, and all these different details. This is what gets sent to the microservice, and then it registers these details as part of the tenant information.
So that ultimately gets stored back inside of the that DynamoDB table that you showed inside of your diagram earlier.
Yeah, and okay, the DynamoDB table I showed was for tracking the overall process.
The process.
The details for the account provisioned will be in the part of the tenant information. So yeah, and this will be stored by tenant. I haven't shown the backend for tenant management microservice, but it is usually a DynamoDB table as well. So it is another DynamoDB table for holding this metadata about the tenant, which includes also the information of the account holding the data science environment, like where the data science environment for this customer lives. Now I would like to show you how the launching process for the SageMaker Studio works. So give me a moment, I will reshare my presentation.
So at this point in time, Islam, while you're bringing that up, once that is executed, the new account for the tenant has been created, and because of the product that's happening with the services, all the appropriate services have been installed into that account as well.
Right. This magic is taken care of by the stack sets, right? So this account is created under the MLOU, right? And what we have specified in CloudFormation stack set is attached a specific stack set to this OU, which means any account created under this OU will get an instance of this stack set, which creates a SageMaker environment for them.
And if say particular customers or tenants have their own specific needs or requirements of that workbench, you could then use. Would you use different versions in the service catalog or different products?
Yeah, in this case, I can use Service Catalog rather than using CloudFormation stack set. And in Service Catalog, I can have variants of this data science workbench environment. One, for example, that allow public outbound internet connection to download libraries and so on. Another one which is fully private, for example, right, for different like departments or something of that sort, depending on like compliance requirements, security requirements, or anything of that sort. And I would change the orchestration a little bit to invoke this other product on top of the provisioned account, basically. So you can also take care of that using Service Catalog.
So whether you're deploying a model that the SaaS organization has created and is just providing, let's say, an instance of that for each of their tenants, maybe to do additional model training or what have you, with that's what we're seeing here. But if a customer wanted to have a bespoke model or a model that is customized to themselves, we have the way of using Service Catalog to do that.
Exactly. That's where Service Catalog will become very handy. Another interesting thing is now we have provisioned this data science workbench. How it will be launched within SaaS, right? So SageMaker Studio exposes an API that allows you to generate a pre-signed URL for the studio, right? So what we are going to do is actually call this API, generate a pre-signed URL, and this is what we're going to use to launch the SageMaker Studio within the SaaS. It's not going to be within it. It's more like in a separate tab. But the users will not have to re-authenticate. So if you looked into the flow, the data scientist logs into the application first. They will be redirected to the hosted UI of Cognito for authenticating. A token ID, an ID token is returned back from Cognito. And then a call is made to the data science workbench management to launch the SageMaker Studio. This basically, here we need to first get the tenant information, which is what we stored earlier during provisioning from the event published from the control tower, right? So we get the information like mainly the account ID. And then using this account ID, we assume a role. So now we know which account we need to connect to generate the pre-signed URL. So we assume a role.
Recalling back to the earlier diagrams as well, just to reiterate, this SaaS portion that we're looking at here, this is a SaaS account. These are all pooled resources, right? That's just part of the SaaS provider's resources, not yet the customer's account information.
That's right. So we call the tenant management service. We get the information about the account where the SageMaker environment for this specific customer lives, and then we create a profile for this data scientist. If it is the first time for this data scientist to use the data science workbench, we are going to create a profile for him in SageMaker Studio. And there's an API for that. So we create a profile for them. And then we call another API for generating a pre-signed URL for a session for that profile. Return this to the front end, and then the front end uses this to launch SageMaker Studio. Let me show you, some of these API calls as well to make it more tangible.
And this is building SaaS on AWS, while Islam is doing a quick change in screen sharing. I can just give you a quick recap. We're talking about data science workbenches in SaaS using Amazon SageMaker Studio. So There we go. Islam has a new screen share up. If you have any questions, comments, just put them in the chat, and we'll do our best to answer those. And we also have Bill with us in the chat, answering questions straight through this hour, what it looks like.
So this is the SageMaker Studio. It is already created in this account using the automation process that I just explained. We have 3 user profiles created so far on this. So what we're going to do first is create a new user profile for a data scientist who is logging in for the first time on the cloud, on the data science workbench, SageMaker Studio, basically. So I'm going to simulate these calls again with commands, but as Anthony was saying, these calls are achieved programmatically using SDKs, AWS SDKs, right? But I'm simulating it with a command line, with a CLI call right now. So we need first to create a profile for the data scientist and then generate a pre-signed URL for them. And this is what will be passed to the front end and used for like opening the SageMaker Studio. So let's say this is the name. Okay. Now I created the user profile. If you go to SageMaker, refresh this view. So we can see now the new user. We'll make another API call to generate a pre-signed URL for that user.
The pre-signed URL, then would you then store that along with that tenant's information or that user's information so they could get back access to it, or is this something that you call multiple times over time?
No, it is. It's actually generated dynamically when the request is made to launch SageMaker Studio. So the same way that you have here you have Open Studio, right? This will launch SageMaker Studio to you. So you will have a similar pattern inside the SaaS. When you click in this pattern, this magic that we explained happening in the back end will take place. A pre-signed URL will be generated, passed to the front end, and this is what will be used for opening the SageMaker Studio.
Excellent.
Right, so this is, I copied this pre-signed URL, and then you put it here. It will open up. It takes some time for initialization, but this will open up. Let's give it a few seconds. And this, once you have SageMaker Studio, you get access to all SageMaker capabilities, like training jobs, data processing jobs. You can do feature engineering with another feature called Data Wrangler. You can, this model produced by the training jobs, you can deploy them. You don't have to worry about the infrastructures that need to be provisioned for hosting a model. That is what SageMaker, hosting capability, become valuable. You can just share, give a pointer to the model, and then it will host this model for you without you having to worry about infrastructure, instance families, or instance sizes, or auto-scaling, and all of these complexities, right? So
if you, say, want to restrict access to certain features, would that be done through what you have in like a product in Service Catalog, or is that through IAM and setting policies?
Yeah, you can control this with IAM. You can also use, so we talked about organizations and the fact that we have OU for ML accounts. This allows you to define guardrails, broad guardrails. For example, blocking the users from using regions they are not allowed to use.
Right.
Do you use SCPs for that? Or
Exactly. Service control policies can be used for that. And of course, you have level of control with IAM as well. Right. So it usually takes a little bit of time to come up. Maybe I walk you through. Yeah. So it's up now.
This is just to prove that it's a live demo, nothing pre-recorded.
That's
we would have
right.
skipped past this part in that case.
Right. Yeah. So here, this is the SageMaker Studio. It is based on Jupyter, Jupyter notebooks. So if you used to use Jupyter notebooks, you'll find the user interface familiar. We have added a lot of add-ons and extensions to make it easier for you to use to perform the ML tasks. You can see, for example, here you can create a data flow. This is a data wrangler functionality that I talked about. You can use this to do feature engineering visually. Like you don't have to do coding for that. You can create feature groups. You can create notebooks, and get access to all the capabilities as well, like ML ops stuff and training jobs and data processing jobs, a whole bunch of things.
One of the things that you mentioned earlier, I think, is important again to note here. By using the account per tenant methodology for deploying these services in, now the data scientists that come in, these profiles that we've created, these SageMaker Studio instances that are up and running, it makes it an easier process to understand also what kind of spend is happening for the SaaS provider right at this point, because there's a lot of services that are starting and stopping and coming in and out, and having them in an account makes it easier to gain that information.
Yeah, exactly. If it is just one SageMaker domain, okay, so for example, when you go to resources, right, here you can see all the endpoints deployed, or you can see, for example, all experiments that are running right now, and all these details. You need to make sure, if it is a pool model, you need to make sure that the details shown here are just for this specific tenant. And this is not an easy thing to achieve in the pool model, right? So you need to, and the problem is if you missed any of these, right, the damage is really big, right? So you can reduce the risk and reduce the complexity by using the silo model for this specific capability.
So you're also not only gaining the benefits of cost allocation, but certainly limiting your blast footprint of a potential data leak or a tenant isolation leak as well.
Exactly. I would like to show you how another interesting use case. So let me stop sharing the console. I will share my presentation. Sorry.
Just while you're bringing that up as well, Islam, I'm not sure if you were planning to discuss this or if it's coming up next, but one of the big aspects, of course, of using any sort of machine learning framework is the data, right, and accessing the data. How does that play into this whole scenario?
Great. Let's discuss this first, given that you brought up this question. So, yeah, let me bring up my slides. Great. So this is actually, so we talked about this very briefly. We said we are going to have a data management service, right? And this data management service will do the magic, right? Export the data from the SaaS and put it on S3 bucket. But how this will work in detail, actually. So what I'm using in this solution is Glue. This is a core service, or the key service that's going to help with this use case. So actually, Glue is a data integration service. It is serverless. You can use it for doing retrieving data from a variety of sources, doing transformation, and then publish the transforming data to, many different types of destinations. In this case, we are going to use it for extracting the data from the transactional database and publish it to S3, where it becomes accessible to the data science workbench. So we're going to use Glue for that. And another thing worth mentioning is this data will be extracted from a transactional database. And we don't want to impact the transactional activities with these data extraction and data science activities. So another suggestion that we made here is to provision a read replica just for this data extraction requests. And have, of course, and then Glue will connect to this read replica to retrieve the data. The end-to-end flow will look like this. The data scientist logs into the application, initiate the data extraction requests. and sends this to the data management service, passing all the filters required, all the data range requirements, like from date and to date and all of these things. Again, it is a multi-step process, so we're going to track the progress in a DynamoDB table. First, we'll publish this request on a queue. This can take minutes, and in some extreme cases, it can take hours as well. So it is asynchronous process. That's why SQS comes into play. We put a message with the data extraction request. We put a record or an item in DynamoDB table for tracking the progress of this data extraction request. Then a data management worker picks up this request and work on it. This involves getting the tenant information first. You need to know which account, what is the account for the data science account for this specific tenant to publish the data into it. So it retrieves these details from the tenant management, initiates a glue job, passing in these parameters like the destination of the data extraction and the tenant identity. And then this glue job will, and then update the DynamoDB table saying the data extraction is now in progress. The glue job will extract the data from the transactional database and then publish this to S3 bucket, right? So this is a conscious decision that we made. We didn't want to, the way that we are pushing data to the data science workbench rather than allowing them to pull the data actually is a conscious decision that we made. And there are multiple benefits for this approach. One is this account, as I said, the customer will have wide permissions on this account to support agility.
Within the customer's account, you're saying?
Within the account, within this dedicated account for them. Right, we didn't want any outbound connection from that account to the SaaS account. That's one thing, and of course we wanted to have protection for this data source, right? For this transaction database, we don't want any customers to overwhelm that with requests. Having a queuing mechanism in place and not allowing direct access, allowing more of a push rather than a pull, allow us to put this control in place and manage the load on this transaction database. Although we're using read replica, not the primary instance, but still we need to manage the load on that. And that's why we use this approach.
These services also that you're mentioning here, I think it's important to note, this data management service, the data management worker, these are still going to need to be bespoke implementations, right, for the SaaS provider, because the information and how to query the data to actually get it into the customer's account for the machine learning to work is going to be pretty specific based on the use case of that customer.
That's absolutely right.
All right. We are quickly approaching top of the hour now, fellas. So I think it's time to wrap up. Islam, do you have any last thing you want to show, or is this it? I think it's been a lot through this hour, to be honest.
Right. I just wanted to mention that these patterns that we showed today and these concepts are explained in a blog post. We're going to share with you the link for this blog post. Have a look into it. There's a little bit more content in that blog post, especially about how to integrate the ML models that you develop in this data science workbench back to the SaaS. So there's a section there about that. Have a look into this and feel free to reach out for questions about that. That's pretty much it. That is key things that I wanted to explain.
Also, are there any plans in the future to create an example architecture, a reference architecture around these solutions?
Yeah, right. We are planning to publish some implementation for some of these parts. As I said, many of these are bespoke kind of components, and community will not benefit much from publishing sample implementation for that. But there are some pieces that are general enough and can be beneficial for the community. So we're working on identifying these pieces and hopefully we'll publish them on GitHub soon.
Anthony putting the pressure on Islam.
Yeah, no pressure, Islam.
That's great. All right. So with that, I shared a link to the blog post in the chat. We've also shared a link to a survey. So if you enjoyed this session or if you didn't, please take the survey and Let us know what you thought and how we can improve perhaps in the future as well. So with that, in this episode, it's been a deep dive as always. We've looked at machine learning for SaaS, not only for the SaaS providers, but actually for the SaaS customers, and how we can use data science workbenches with the help of Amazon SageMaker Studio and integrate that into our SaaS product. I think it's been super interesting. This has been a great episode as always in this series, if I'm allowed to say that. So Islam, thank you very much for joining us today, and Anthony as well for joining. I hope you enjoyed it as much as I did. And
Absolutely.
And with that, thanks to you both, and thanks to all the viewers. And this has been another episode of Building SaaS on AWS. And I hope to see you next time again. Bye-bye.
Bye-bye.
Bye-bye.